Hello and welcome back to this performance test of the Synology DS720 Plus. Today we want to look at what are the benefits of NVMe SSD cache on the brand new DS720 Plus 2-bay. Now, NVMe SSD caching on Synology NASs isn't a new thing. This isn't, I think this might even be the 6th or 7th device in their product family that has arrived with NVMe SSD caching bays. But it is the first time we've seen Synology, a company that's heavily associated with their software, actually going to the trouble of including NVMe SSD caching with 2 hard drive bays, arguably a little bit overkill. Now on this NAS, we've installed 2 hard drives, and these 2 hard drives are Seagate IronWolf NAS drives, and we've got them, these 14 TB drives, in a RAID 1 environment, otherwise known as a Synology Hybrid RAID, thanks to their own flexible RAID system. And we're going to be doing some performance benchmarks on this. We're going to be using 50 to 60 gig of files. We're going to create multiple copies of it, read-write actions, all simultaneously, and then we're going to be zipping those files up and creating like compressed versions of them, and then finally we're going to repeat the whole process again, but this time using SSDs. We're going to utilize the Seagate IronWolf 510 NVMe's in an SSD caching arrangement, because we've not done it yet, as you see. And then we're going to perform the same actions again on those hard drives, but this time using the cache. And what we want to see is there any performance benefit during this operation? Now, first and foremost, this isn't going to be the biggest test of things. We're not running a VM or surveillance. We're not running anything where there's the same small files being accessed on a very regular basis. This test is more of a microcosm example of an overall testing of NVMe SSD caching on a 2-bay NAS. So this may not be indicative of your own personal setup. But without further ado, let's go ahead and go straight to the testing. Now, we have got inside here, we've got our 2 hard drives, as you see in that storage pool. And if we make our way into the file manager, you can see here I've created a folder on this NAS that contains around 60 gigabytes of data. It's around over 200,000 files, and that is across over 2,500 folders. So that is a huge amount of data to be playing with. Notwithstanding the fact that all of these operations are going to be simultaneous, with all of them happening 3 times on the same hard drives generally not known for being great for multi-access environments like this. And we're going to see how long it takes the system to perform these actions. So if we get the stopwatch up there and reset it, what I'm going to do is first click copy. So we're just going to copy the content of that folder. Then we're going to create 3 folders, one after the other, and then copy into them. I'm going to start the clock and then start building those folders so we can get a timestamp on it. But without further ado, 3, 2, 1, go. I'm going to create folder number 1 and quite literally call it 1. I'm going to go into it. We're then going to paste into that, create another folder, create that folder, call it 2. Go into folder 2, once again, paste, go back into the main directory, create the folder, call it 3. Go into that and paste the data. And then we're going to go back, bring the performance monitor in the background task there, and bring the clock back onto screen. And then we're going to see how long it takes this NAS to perform this action. In fact, let's get the resource monitor on screen simultaneously so we can have some idea about how the system is going to behave with this testing environment. So let's bring that there. Let's bring the chart there at the top and get rid of OBS. Leave the clock timing it here in the background. And what we're going to do now is fast forward and see just how long it takes this Synology NAS to complete this 3-part simultaneous read-write action of just 60 gigabytes of data. as you can see, our tests are reaching the end of their run. They're about 98% done, and we're just shy of an hour. We're at 55 minutes so far this process has taken, and the CPU and memory has been on throughout, and it has been kind of jumpy. You can see the volume utilization has gone nuts there, but other than that, the CPU and memory kind of adjusted throughout. I'm going to get ready on the pause button there at the completion of this operation. But we can see that these 3 simultaneous duplicates from this hard drive here, and now we finished it, took 55 minutes and 26 seconds. Now, that may seem like a huge amount of time, and had this been a single operation of one copy action, I would have agreed with you. However, because this is a multi-stage 3 simultaneous write from the same drive, the SHR that it's being read from, those kind of speeds are sort of what you might expect. These are enterprise level drives, and in fact, if you were using bog standard drives or using non-Pro Series NAS drives, the speed would have been even worse. But for now, what we're going to do is now perform those same actions, this time, but with using these drives here, we're going to perform a zipping. There we go, I nearly forgot the word. We're going to create an archive of these 3 separate folders, and we're going to see how long it takes the NAS system without caching to do the archiving. So we're going to do an archive here. We're going to call it just one normal archive. We're not going to give it any kind of priority. We're just going to use the default settings for all 3, and we're going to create our archive. So now we're creating 3 archives. Again, we are reading and writing to the same hard drive array. So this is going to take quite an amount of time. Now, if we look at the clock here, let's get that clock started. We can somewhat forget about the overall time so far. And the time right now is 4:27. And what we're going to do is fast forward to the completion of this operation to see how long this takes. Okay, so I'm pleased to confirm that it did complete the 3 zipping archive directions that we gave it, the DS720 Plus. And as you can see here, it started around about 4:30, just before, and ended just after 6 p.m. of that same day. So if we have a little look, we can see there the overall scores so far between the archiving. Now, it took 55 minutes and 26 seconds for all duplications of that original folder to be completed, and 1 hour 33 minutes from the beginning of the start of the first archive to the completion of the third one. So again, a good amount of time and fairly respectable for a NAS of this hardware. Now we're going to move over to testing with that SSD caching in read-write environments. So what have we got in here? First thing we'll do is we're going to delete all of the files that we've created here. So if we go ahead and delete those permanently. And for those that are curious, I'm pleased to confirm that this folder does not have a recycle bin. If we move that out of the way and hide that, you'll see that this folder does not have a recycle bin, so this information will not be maintained. And I have already created a cache in advance, but that caching has taken place after the completion of this operation. This cache was built around about an hour ago, long after the completion of those original tasks. So right now, that cache doesn't have these files in the background, and the deletion is happening there in the background of the NAS. And as soon as those files are deleted, we're then going to start redoing all of the tests we did earlier. So let's start creating our folders. So we're going to call this 1A, call it again 1B rather predictively, and finally 1C. So again, as these files are being deleted there in the background, it will then remove them, and we can start copying that large scale of data there. As you can see, if there were files that were living on the cached portion of the drives, highly unlikely given it's only been around for an hour and we've not interacted with this data, that data would also be deleted from the cache. It's also worth highlighting that this cache is also supporting several other services such as Plex Media Server and a few other indexing tools in the background. Again, SSD cache is largely a feature that benefits most of the operations inside your NAS, and utilizing it is always beneficial. I'm going to fast forward to the completion of the deletion of these 6 files so we can begin the second stage of testing. Right, so the deletion has completed. We've got the cache knocking around there in the background, some of it being generated by Plex, I imagine. And we've still got the 64 gig of data inside that folder, with all 3 of these brand new folders completely empty. So what we can do now is we can go ahead and start building our 3 duplicates of this data within the NAS. We're going to get the timer up, and let's bring that there, and we've got that reset to 0. And we'll get the cache on screen and let that do its buzzing there in the background. But the one we want to look at is that one there. Let's get the clock back on screen and let's start our copy procedure now. So we'll go ahead, we'll click copy, we'll go into the first folder, we'll click paste, we'll go into the second one. And again, I'm well aware that there are quicker ways to do the operation of the copy paste, but I want to make sure that you guys can see that I'm doing this clearly 3 times manually, one by one, with all 3 happening simultaneously here on screen. So we've got the cache buzzing around there at the bottom, and we have got the clock here, and we're going to be able to get the resource monitor as well. Try and get as much of the stuff here on screen simultaneously as possible. Again, it's going to be quite tough to fit this all in, but we'll try our best, and we're going to leave this to complete. So, things to bear in mind. During this operation, if we get that up on there, we have done tests not dissimilar to this in the past. We've run tests where we've been doing copy-paste procedures, where we have copied files from RAID 5 enabled NVMe SSD caching scenarios like on the 918 and on the 1019 before. But the difference is this is a 2-bay. So the 2-bay will present a slightly different environment for this kind of operation. I am seeing that it's certainly doing the job faster. It's already clocked that we are dealing with the same files in one location, and caching has already seemingly gave us a bit of an improvement here. Generally, we find that this kind of operation in the past with a RAID 5 has given us somewhere between 12 and 15% performance improvements. But given that this is an SHR with 2 Seagate Iron Wolves in that SHR environment rather than a RAID 5 or a larger hard drive array, and those 2 NVMe's buffering, it's going to be interesting to see what the performance difference is going to be. Remember, the score to beat is 55 minutes and 26 seconds. That was the SHR with no caching versus this SHR with read-write caching. Let's fast forward to the completion of this move. Right, so we're at the 50% mark, and by the looks of things, we are just under 20 minutes completed. So we are definitely seeing a marked improvement in read and write speed. However, it is worth bearing in mind that we don't know if the files that are being transferred as we speak are the smaller or the bigger files. The transfer of the previous files that we sent earlier may well have left the larger files early on. We don't know if the remaining 48% of these files are still the larger ISOs. There is all manner of big files inside here. We've got zips, we've got archives, we've got media images, but we've also got thousands of images spanning PNG, JPEG and more, as well as some CSVs, PowerPoint documents and PDFs. What I'm saying is, despite the fact that right now we're looking at 20 minutes gone and over the 50% mark, we don't know what files are in the other 50%, so there's still everything to play for. However, based on what we're seeing here, it does look like this process with the SSD caching in that 3-piece SHR write in conjunction with the NVMe cache is going to complete somewhere in the 40-minute mark, which is great, which will give us that marketed 10, 12, maybe even 15% that we were hoping for, but we've still got the archives to do after that. But nevertheless, let's fast forward to the completion of the exercise. And now we're reaching the end of the testing. OBS still running there in the background. We're up to 97% overall with 98 at the end there. Some interesting things to take away first thing while we get ready to pause this task. We've only utilised 43 gig of caching, so not all the files in our directory were cached. So again, I was a bit surprised by that. I thought the caching would be a little bit higher there. I thought it would utilize around the late 50s at least, because I know some core files wouldn't have been cached because they're too large. But as we pause there, it has taken 41.58 minutes to complete this task. So 41.58. So let's enter that into here. 41.58. And while we're at it, let's take a moment and have a look at what that does to the percentages here on a title here I have in the background. So let's enter that in there. 41.58 equals that this took around 30% quicker, so way higher than I anticipated. So there's lots of reasons that could have been the case, but it was certainly faster. That does seem a little bit faster than even I would have anticipated for this test, so I might do a bit of investigation there in the background. I definitely expected it to be faster, but 30% does seem a little high. I might double check my numbers there, but that's still a big chunk of difference between them. Maybe my maths is off, but again, great results there of the completion of that three-way duplicate. Certainly, we saw volume utilization a consistent high throughout that whole test, and that is some great numbers there with the NVMe SSD caching. And of course, that's largely because it is the 510 series, which really does ramp it up a great deal. Now, what we're going to do now is replicate the second part of that test, and that is the archiving of all three of those, and we'll see how long that takes. But for now, let's get that test started. Let's reset the clock, although chances are I'm not going to have the clock running during this because this process takes a great deal longer and the screen recording alone prohibits a lot of other things. But for now, what we're going to do is we're going to look at the time that this is starting. This is starting at 11:57, and we're going to begin our caching of these files, or not caching, what can I say? The archiving of these, which is effectively creating a zip of each folder. So I'm going to start now, and again the creation time will be noted by the system let's get rid of that. We'll go ahead there and create the compression there of that archive, and we're going to let those carry on in the background while it creates those compressed zips of these three files. Now, once again, in the previous testing, what we saw was that it took 1 hour and 33 minutes. We fully anticipate it to be pretty close to this. The difference is that a lot of the data that we're dealing with would have already been cached in the previous test, and I think that could well slice off some of the completion time of this. Now again, at the end, we're going to be able to look at the modification date, and it should be able to tell us just how long this has taken from the beginning to the end. And it's going to be interesting to see how and when this finishes. So let's fast forward to the completion of the three-way archive of this test data. CPU utilization is already astronomically high, but as this test proceeds, that number will decrease over time. So let's fast forward. Right, so we're around 28% completion on the compress here, and again it's sort of vectoring between all three of them. We can see a quick update on the time there, just how long it's taken, and of course we'll make a note of that. The reason I'm adding this little stopgap here is for two reasons. One, you may see that the resource monitor is going absolutely crazy there. The amount of memory we're utilizing on this network attached storage device, we've got 2 gig of memory, and we're already at the 80% threshold, along as the volume utilization and that CPU utilization is pretty high indeed and spiking regularly. Additionally, we can see down here at the caching arrangement that we have already spiked up now to 58 gigs. So caching is being utilized during this process. It's been constantly activated with the hit rate always above 70 or even 80%. But what's interesting is we are utilizing, and it is growing over time, cache utilization during this process of creating these 3 archives. It's not done yet, and at 27% here you can already see the time we've started and the time we completed. There's a time earlier on for when we were doing the bulk files earlier. But let's fast forward to the completion of this. I just wanted to add this little note in the middle just to see how the system is adjusting and the cache is growing during the course of this operation. And it may well go along that line that we're going to utilize the entire cache on this operation, and then it'll be nice to see if it does flush the cache afterwards. But let's fast forward. So we're reaching the completion of the 3 zip creations that we've been doing of these files. And as we can see here on screen, as they draw to a close, we can quickly update the speed there. And of course, the modified date will keep changing as these are being created. But we can see that the time compared is actually remarkably similar. We've seen a huge growth there in the cache being utilized in real time here. But overall, as this completes and that first zip is being completed, remember we're timing the creation of the start of the first one to the end of the third one, the time difference between the archives being created without cache and with cache is actually surprisingly small. We've generated a lot of SSD caching there in the background, but I think the difference is barely going to be 6 or 7 minutes between them. So we're going to wait until these finish and then we'll do our math together. But we can work out there as one finishes there, we've got our first one readily completed there. And that first one took around 1 hour and 22, maybe just shy of 23 minutes. And again, that was 1 hour 33 for the first one, but we're not going to complete this until it's absolutely done. And this will refresh as those other compresses complete. But the difference is so small, I think, this time. Although there is a difference, it's not vast between these two. Obviously, it's nowhere near as big as that difference between the duplication of those folders that we saw earlier on, that we're utilizing the standard hard drives versus the hard drives and SSD caching. But as this draws to a close, it's refreshed there. The time difference between these two, it's not really going to warrant any advantage either way. So the second compress is completed as well. That's at 21. I think the other one's going to be done any minute now, and there it is. So we can look at the time difference between them, and we can have a look and work out that the time difference between them is 1 hour, 23 minutes and 12 seconds. Put that in there. So the time difference between these, again, around about 10 minutes, which is still something to write home about, although it's not vast. It's nowhere near as vast as the difference we saw previously when we were utilizing this. And remember, this has been utilizing hard drives and using SSD caching to assist things. Now, bear in mind, we are talking about relatively small capacities. We did see a huge increase there when it came to the duplicating of multiple folders, but there's no avoiding it. Even one look at the CPU and memory here, that this NAS was bottlenecked in the case of the archiving by the CPU and the memory. And because of that, this ended up being a glass ceiling that, regardless of the SSD caching or not, was just not possible to achieve higher results by any significant degree than what we saw without caching. But for me personally, this still does show that SSD caching certainly has a place in traditional access. Now, I will be including these SSDs for caching in my Plex Media Server test video, where I will be showing the performance of the DS720 in Plex Media Server, and hopefully seeing if NVMe SSD cache can be of any use in that scenario. Probably not, given that memory is a much bigger player in that arena, but it will be interesting to see nevertheless. But I hope you guys have enjoyed this video. Lots more like these to come. We will be doing a not dissimilar test to this using the DS920, and I look forward for you guys to check that out. But thank you so much for watching. I hope you enjoyed this video. Click like if you did, click subscribe to learn more, and I'll see you next time.